Well, welcome to this edition of Round the Dial. Today's instrument will be the 61797, which is the higher end insulation tester. As you can see, the unit itself comes with test leads and with removable alligator clips. Those just are press fit on. So we'll leave that on for a little bit later. The unit, it also comes with a remote probe, which can be plugged into either the voltage insulation side, or the resistance side to do testing by hooking it up to probing whatever device it is that you want to test. And this end cap, of course, removes, and then pressing the test button to complete the test, or to perform the test, I should say. Now, what we'll do is we'll start by turning the unit on, and we can see that the unit will measure both voltage AC or DC up to 600 volts, auto sensing, and then it also has LPF. LPF, or low pass filter, is functionally exactly the same as on the tight side series of clamps, which has the HFR, high frequency rejection. What it does is it ignores any frequencies above about 300 hertz to give you a much more accurate measurement of voltage in the presence of higher frequencies, such as you would find around things such as high frequency drives, as just one example. So you can toggle that into the LPF on or off. Next we have ohms. So to measure ohms, we would put the lead in the ohm selection, ohm terminal. We would then short out the leads, and we would press the test button. Now we can see very, very good, very, very low resistance, 0.00 ohms of resistance. So literally, right down to 1/100th of an ohm is the resolution that this device has for resistance. That can be very, very handy when checking things such as connections in a grounding system, to make sure that a connection does not have excessive resistance and has a very low impedance, low resistance pathway for current flow on the ground. We also, now we'll open these up. I want to press the test button one more time with the leads open. And we can see now that it's 40,000 ohms. Actually, it's greater than 40,000 ohms, or 40.00 k ohms, as the display shows you. And that means that it's gone to the maximum, because there's a lot of, essentially infinite resistance between these two test leads. Now we can see that the next up the dial, we're going to 50, 100, 250, 500, and then 1,000 volts. Now here's something that's common to all digital insulation testers. Depending upon the applied voltage, test voltage, there's going to be some value that it can read up to in the way of resistance. So we're going to test at 50 volts. The leads are not attached to anything, and we press and hold the test button. We can see the red light has illuminated, the icon, the lightning strike icon is illuminated. We can see that 55 volts DC is being applied, and because of the infinite resistance, we're getting 55 megohms. That's the maximum that can read, but it measures or exceeds that value. We'll stop the test, and now at 100 volts, we can see it's applying 111 volts, and it's returning a value of 110 megohms of resistance. Let's do the same at 250. And we can see it applies 275 volts and 275 megohms. And incidentally, I encourage every customer that I speak with, get into the habit of running this test with nothing attached first, so that you know exactly what the resistance is, that the maximum resistance value is. Okay, at 500 volts, we press it and hold the test button. 550 megohms at 525 volts. And then lastly, at 1,000 volts, we press and we can see it's applying 1,052 volts DC and returns a value of 22 gigohms, 22 G ohms of resistance, so very, very high. So what we're going to do now is set the tester up to do a test of a cable. Now, we're pressurizing with the red lead. Pressurizing, we're applying the voltage. So we're going to test from hot, I should say, to the neutral. So we pressurize with the red lead, and we see with the black lead is anything flowing or any electrons escaping from the hot to the neutral. So we're going to come back down to 50 volts for the test. We press and hold until we have a stable reading. So we can see it's applying 54 volts, and it's measuring about 0.514 megohms. So about 500,000 ohms is the resistance. So we have something that's very, very suspicious going on between the hot and the neutral. So now just to check, I should say, we're going to check onto the ground, and we're leaving the pressure or the voltage on the hot and coming to the ground. And now we're going to press and hold the button again. And we see that it's applying 55 volts, and it's measuring 55 megohms. So the problem is most definitely between the hot and the neutral. So and now with the lights gone out because we've stopped the test, we're going to put this back here for a slightly later test that we're going to do. So we're again checking between the hot and neutral. Now, if we press the comp button, or compare, we press that and we see that 100 K ohms comes up. All that simply means, that compare means I'm looking for a value. I consider any value above 100,000 ohms to be good. That's totally selectable by the end user, and it's up to them to select whatever value. For me, 100,000 is very, very low, but it's all dependent upon, that's all this function does, is you select a value and then run the test. So the values are 100 K ohms, 200 K ohms, 500 K ohms, 1 mega ohm, 2 mega ohm, 5 mega ohm, 10, 20, or 50 mega ohms. And then it'll toggle back to 100 K ohm again. So as long as it's above, we're running this test right now, so as long as it's above 100 K ohms, you'll get the green light, and I'll show you. So we press the test button. It gets a stable reading of 0.465 mega ohms. Obviously, that's greater than 100 K ohms. And the green pass light came on over here to say, okay, great, I got higher than the value I set. That's all that does. Next, we may want to lock, oops, I'm going to do this just to get it out of that function. In some cases, we may want to lock the unit on for some period of time. So we hit the lock button, the lock function appears in the screen. We press the test button, red light comes on, a lightning bolt comes on, and now the unit will stay on until the batteries, we either stop it or the batteries run out, of course. So now it's just on, and you have to be cautious that there is a voltage potential at the two leads that you've hooked up, or to the conductors that you've hooked up to, of course. So I'm going to take it out of that test mode. And now I'm going to go back to the lock button, but instead of just touching it, I'm going to press and hold to get into the PI and DAR selections. PI, these are two almost identical tests. The only thing that is different is the length of the test. PI stands for polarization index, and it is a 10-minute test. DAR stands for dielectric absorption ratio, and is a 1-minute test. So we're going to slide over to the DAR and perform a 1-minute test here. And while the test is running, a couple of things. I'm going to press the blue button now, so the timer came on, so the countdown timer is now running. Now what happens in this particular test is it's going to record the value that it sees at 30 seconds, and then it's going to record the value that it sees at 60 seconds and divide one into the other. And what happens is it'll return a result of, it could be 0.6, 0.7, 1.0, 1.2, 1.3. If it's 1.1 or higher, it simply means that over the duration of the test, the values got higher. I'm going to try to move things around a little bit here by moving the cable, the issue that I've got with the cable. And that would typically indicate that things are good. If it's 0.8 or 0.7, something like that, that means it fell over the duration of the test, and that's highly suspicious. But you also have to take into consideration the length, or the actual value of the resistance during the test. So you can see in this particular case, when it finished at 1 minute, it was 1.8 times the value it was at 30 seconds. So I'm not saying that that's good because the values were very low, but that's what the PI and DAR tests are all about. And with that, I'd like to thank you for joining us for this edition of Round the Dial.